Okay, welcome to the first marathon on conservation of energy. Let's start solving this question. It says a cyclist and his machine have a total mass of 80 kgs. The cyclist starts from rest at the top of A. Okay. Um, of a straight path and freewheels moves without pedaling or breaking down the paths. AB. The path AB is inclined 2.6 degrees to the horizontal and is of length 250 meters. Given that the cyclist passes B with a speed of 9, find the gain in kinetic energy and the loss in potential energy of the cyclist and his machine. Hence, find the work done against the resistance to the motion of the cyclist and his machine. Okay, since he's freewheeling, that means there's no driving force involved. So I can find the change in Ke first of mv square minus u square. Okay, so quickly calculating that, I get 81 times 80 divided by 2. 3240 joules. There is a change in P and it's a negative change. Why? Because the height is decreasing. So I have M minus M G and H should be 250 sine 2.6. Okay, I'm considering a right triangle here. This is 250 sine 2.6. Okay, so minus 80 into 10 into 250 sine 2.6. Uh, my calculator is not in degrees. Okay, so that's minus 9072.560. Let's keep that. I have to round this off to three significant figures for the final answer. Um, okay. Hence, find the work done against the resistance to the motion. So I'm going to write my formula: work done by driving force equals to change in Ke plus change in P plus work done by resistance. Okay, this is 0, this is 3240, this is minus 9072.60, and this is what I'm trying to find. Okay, so 3240 minus 9072.6, 5832.6, which is 5830 joules. I'm writing an extra number of decimal places just in case I want to uh, use it in the next question. It says the cyclist continues to freewheel along a horizontal path AB until he reaches the point C where the distance BC is d centimeters, his speed is 5. The resistance to motion is constant and it's the same as and is the same on BD as on AB. So there was a constant resistance to the motion. So this work done by resistance can now be divided by the distance to find the resistive force. Okay, okay. So part 2, 5832.6 is basically 250 into the resistive force. So I get 5832 divided by 6 divided by 250. I get 23.33. 04, 28.33. I'm going to use my formula again and I'm going to say that work done by driving force, change in Ke, change in P, plus work done by resistance. This time the work done by resistance is now 23.33. into D. There's no change in P. Half M V square minus U square. Work done by the driving force is 0. So 40 into 5 square minus 9 square divided by 23.33. So D is about 96 meters. And says the cyclist starts to pedal at C, okay, generating 425 watts of power. Find the acceleration of the cyclist immediately after passing through C. So if he's generating a power of 425 watts, power equals to FV, power 450, 425. My speed right now is 5. So I get 425 divided by 5, 85. So what are the forces acting on the cyclist? He's driving with 85. He's getting resisted by 23.33. So 85 minus 20.3 equals to MA. M is 80. I can then solve for A. So I'm getting 0.77. Yeah, 0.771 is my acceleration. Okay. Question number 2. P and Q are fixed points on a line of greatest slope of an inclined plane. The point Q is at a height of 4.45 meters above the level of P. A particle of mass 0.3 kgs move upwards along the line PQ. Okay, let's draw this first. A particle of mass 0.3 kgs moves upwards along the line PQ. Given that the plane is smooth and the particle just reaches Q, find the speed with which it passes through P. Okay, so it just reaches Q, which means that the velocity becomes 0. U is unknown. So I am going to say that since the plane is smooth, there are no external forces involved. It's only getting resisted by weight. I could do this with Newton's laws as well. Uh, and I could do this with change in Ke could be equals to the change in Pe. Okay, so half M V square minus U square. Okay, I will have to turn that into a positive number or take a negative on the other side because the P will be increasing while this is decreasing. Okay, so zero point 0.3 G and H. Okay, zero point 0.3 cancels out with zero point 0.3. I'm getting, let's put a negative sign here. So I'm getting U square equals to 9, U equals to 3. P and Q are fixed points on a line of greatest slope of an inclined plane. Okay, I think this part is repeated here. Let's take a look at the next part. It says it is given that instead the plane is rough. The particle passes through P with the same speed as that found in part 1 and just reaches a point R, which is between P and Q. The work done against the frictional force in moving from P to R is 0.391. Find the potential energy gained by the particle in moving from P to R and hence find the height of R above the level of P. So I'm going to use my work energy principle. I'm going to say that work done by driving force, change in K, plus change in P plus work done by resistance. So it's 0 half m v square minus u square. Change in b is m g. Okay, first I want to find the change in potential energy, so I have to tell you that as well. Work done by resistance is 0.39. Okay, so the change in P is zero point 0.3 into my divide by 2 to minus 9. 0.3 divided by 2 into minus 9 plus 0.39. So change in P is 0.96. M G and H. H equals to 0.32. Okay, quickly moving on to the next question now. This is question number 3. It says a block of mass 60 kgs is pulled up a hill in the line of a greater slope by a force of magnitude 50 newtons, acting at an angle of this. The block passes through points A and B with speeds this and that. The distance AB is 250 and BC is 1.17.5 meters above the level of A. The resistance to the motion of the block is this. Find the value of alpha. Okay, so I have 50 sine alpha and 50 cos alpha here. Okay, so the work done by the driving force, change in K, change in P, work done by resistance. Okay, the resistance to the block is 6 into 250. Change in P is M, G, and H. Change in K, half M V square minus U square. Okay, the work done by the driving force is 50 cos alpha into 250. Okay, solving this gives me 30 into 3.5 square minus 8.5 square plus 600 into 17.5 plus 6 into 250 divided by 250 divided by 50. I'm getting cos alpha equals to 0.816. Fifth cos inverse answer gives me 35.3. So a relatively simple question for 11 marks. Okay, question 4. A light inextensible rope has a block of mass 5 kgs attached at one end and a block of mass 16 kgs. Uh, 50. Okay. Block A is held at rest at the bottom of the plane and block B hangs below the pulley. The coefficient of friction between A and the block is 1 root 3. So mu is equals to 1 root 3 into R. The coefficient of friction between the A and the block is this. Block A is released from rest and starts to move when each of the blocks has moved a distance of x meters and a speed v. Write down the gain in kinetic energy of the system in terms of v. So half m. M is going to be the combined mass of the two. So 21, because I'm talking about the system now, v square minus u square. Okay, so that gives me 10.5 v squared. Find in terms of x the loss of gravitational potential energy of the system. Now, there are two things happening. One is that P is coming down, so it's losing potential energy, so minus 10, and H is going to be the same because it has moved the distance of this. On the other hand, A is gaining, so I'm going to say that plus 5, 10, and what distance would that have moved? It would have moved a distance of x sine theta. Okay, so x sine theta. So I get minus 160x plus 25x. That gives me minus 135x. So a loss in gravitational potential energy of 135x. The work done against the frictional force. Okay, I will have to find the frictional force first. Mu equals to 1 over root 3. R is going to be the vertical component here, 50 sine 30, 50 cos 30, and R here as well. So 50 cos 30. So frictional force is 1 over root 3 into 50 cos 30. That I think gives me 25. And work done against this would be 25 times the distance, 25x. Show that 21 v squared equals to 220x. So I'm going to say I work done by driving force, change in K, plus change in P, plus work done by resistance. There are no driving forces involved. So change in K is 10.5 v squared. Change in P is 135x. The work done by the resistance is 25x. So I am getting 110x to 10.5 v squared. If I multiply both sides by 2, I get my required inequality. Not inequality, the equality, sorry. So 220x equals to 21 v squared. That's the end of the question. Okay, question number 5. The diagram shows the vertical cross sections ABCD of a surface. BC is a circular arc, and AB and CD are tangents at B and C. A and B are at the same horizontal level, and B and C are at heights this and that. A particle P of mass 0.2 grams kgs is given with a velocity of 8 at A. In the direction of AB, the parts of the surface containing AB and BC are smooth. Find the decrease in the speeds of P as P moves along the surface from B to C. So from A to B, I can say that the change in Ke should be equals to the change in P. I just have to be careful about the positive and negative signs because Ke is certainly going to decrease since it's climbing up half m v square minus 8 square, so minus, because Kp was positive and I had to create an equivalency, so minus m, j, and h. Let's see what that gives me. 7 into 2, okay, minus answer plus 64. So I'm getting v square equals to root of 10. Sorry, v equals to root of 10. Okay, so v equals to root of 10. Then what happens is it still keeps going up. It's going to slow down and then have a speed. But since p is again increasing, I can assume that what has happened is change in k equals to change in p. Again, since p is increasing, I will assume that k is decreasing. That is how conservation of energy holds in without external forces. So mg h is this time 0.3 of m v square minus u square is 10. So I get zero point 0.2, right? Zero point 0.2 m. So I get 3 into 2 minus 6 plus 10, 4. So v square equals to 4, v equals to root of 4, which is 2. So what's the difference between the speeds? It's root of 10 minus 2. So I get 1.16. Then the part of the surface containing CD exerts a constant frictional force on P as it moves from C to D, and P comes to rest as it reaches D. Find the speed at when it is at the midpoint of CD. Okay, so let's talk about change in, there is friction involved now. So work done by driving force, change in Ke plus change in P plus work done by resistance. Okay, it's a constant frictional force. I don't know mu, right? Okay, let's see how this can be done. There is no driving force involved. I am coming down with a speed of 2 square minus it comes to rest at d. V square minus u square. The change in p is that the height is decreasing, so minus m g h. H is 3. Okay, let's calculate the work done by the resistance and then see what we have to calculate. Minus 4 over 2 into 0.2, that gives me minus 0.4 minus 6 work done by resistance. Okay, so the work done by resistance is 6.4. Okay, since the resistance was constant, I can say that when I'm aiming for the midpoint of AB, the work done by resistance will also be half. So I'm going to again say work done by driving force, change in K, change in P, plus work done by resistance again. I'm going to say that this is 3.2. Change in P is, now since I'm at the midpoint here, I can assume that this height is also going to be, they are in the same ratio because I have similar triangles, but M minus 0.2, 10, and 1.5. I'm going to say half M, I don't know, V square this time. I'm going to say that I still started off with that, and I'm going to try to solve this equation. Let's see if I get the correct answer. Okay, I'm getting 1.414, and I think that's the correct answer. Okay, so slightly tricky. Let's go to the next one. It says a lorry of mass 16,000 kgs climbs a hill, straight hill ABCD, which makes an angle of theta with the horizontal where sine theta equals to 1 over 20. Um, okay. Find the motion from A to B. The work done by the driving force of the lorry is 1200,000 joules, and the resistance to the motion is constant and equals to 1240. The speed of the lorry is 15 at A and 12 at B. Find the distance AB. Okay, so I'm going to again use my formula. Work done by driving force equals to, let's write that. By driving force equals to change in KE, half M V square minus U square MGH. So I think I'm going to run out of space. Change in K, change in P, M, G. Okay, now since I don't know H, I can say that whatever distance this is, it's going to be D sine theta plus work done by resistance. So that's 1240 multiplied by D, which is the unknown distance AB. Okay. Again, putting everything on my calculator, 1200,000 equals to 8,000 into 12 square minus 15 square plus 16,000 into 10 into x into sine theta, which is 1 over 20 plus 1240 times x. And I solve and I get an answer that tells me that this is 200 meters. Okay. Then, sorry, this was D. From the motion from B to D, the gain in potential energy of the lorry is 2400. Find the distance BD. And that's simple. Change in PE is mg, and H is again, let's call that again D sine theta. Okay, so that's 2400, 16,000 into 10 into D into 1 over 20. 2400,000. My bad. 2400,000. But 300 meters. It says from the motion from B to D, the driving force of the lorry is constant and is equals to 7200 newtons. From B to D, B to C, the resistance to the motion is constant and equal to 1240. And from C to D, the resistance to motion is constant and equals to 1860. Given that the speed of the lorry at D is 7, find the distance BC. So the entire distance is 300 meters. Okay, let's call that X, and C to D will therefore be 300 minus X. Okay, so from B to C, I have my same equation work done by the driving force, which is 7200 into X. Okay, change in KE is half M. I don't know this V. Okay, so and I know the speed at B, I think. The speed at B is 12. So I don't know the speed at C right now. And I don't want to find that either. Okay. Okay, or I could do one of these things where I go on and just break this up. I don't need two equations for this. I can just do this where I put the entire into one slot and I just break up the work done by resistance into two halves because the other thing is staying constant and it's in continuity. So 7 square minus 12 square. The gain in potential energy is 2400,000 because I'm going to find it difficult to break up 2400,000. I probably have to do a sort of ratio where I do x raised to 300 minus x and then try to break it up. But it's going to make things very complicated. So I can just do work done by resistance in two halves. I can say that it's 1240 into x plus 1860 into 300 minus x. Okay, solving this again on my calculator, 7200 into 300 equals to 8000 into 7 square minus 12 square plus 2400,000 plus 1240x plus 1860 into 300 minus x. Yep, I am getting 61.29, which is 61.3 meters. Moving on to the next question quickly, it says a car of mass 1500 kgs is pulling a trailer of mass 750 kgs up a straight hill of length 800 meters, inclined at an angle of sine inverse of 0.08. The sine theta equals to 0.08. The resistance to the motion of the car and trailer are 400 and 200 respectively. The car and trailer are connected by a light rigid crowbar. The car and trailer have speeds of 30 at the bottom of the hill and 20 at the top of the hill. Use an energy method to find the constant driving force as the car and trailer travel up the hill. Okay, so I want to use an energy method. So I'm going to treat them as one object. In this case, I'm going to say that I have a total mass of 2250 and my resistances are 600 newtons. There is a driving force involved, okay, which I don't know. So the work done by the driving force change in Ke, so half m v square minus u square, change in Pe, m g h 800 meters. So 800 sine theta plus work done by resistance is 600 into 800. Okay, what am I trying to find? I'm trying to find the driving force multiplied by 800 and I have the rest of the equation in front of me. Okay, let's quickly find that. So x into 800 equals to 20 square minus 30 square plus 2250 into 10 into 800 into 0.08 plus 600 into 800. I am getting 1696.875, which is approximately equals to 1700 newtons. After reaching the top of the hill, the system consisting of the car and trailer travels along a straight, level road. The driving force of the car's engine is 2400 newtons and the resistances to the motion are unchanged. Find the acceleration of the system and the tension in the tow bar. Now I'm going to treat them as separate objects. Let's draw them. Okay, the car, which is 1500. There is a trailer there, which is 750. The resistance to the car is 400 and 200. And then I have a driving force of 2400. This tension facing both ways. So I'm going to say that for the car, it's 2400 minus T minus 400 equals to 1500 A. And for the trailer, it's T minus 200 equals to 750 A. T cancels out. I'm left with 1800 equals to 2250 A is 0.8 meter per second square. That is the correct answer. And for T, I'm going to do this. I think T should be 800. Okay, a train of mass 20,000 kgs moves along a straight horizontal road, passes the point A with this, and then later it passes the point B. The power of the train's engine is at B is 1.2 times the power of the train's engine at A. The driving force of the car's engine at B is 0.96 times the driving force of the car's engine at A. Show that the speed of the train at B is 35 meter uh, per second inverse. Okay, so power is force into velocity. Okay, when at A it has a velocity of 28. I don't know its power. Let's call that P and let's call this F. The driving force of the car's engine at B, the power of the train's engine. So at a different time, I have 1.2 P when the force is 0.96 F and I don't know the velocity. That's what I want to find out. Okay, can I make a substitution? Can I say that P equals to F into 28? So 1.2 times 28 F equals to 0.96 FV. FF and F cancel out. 1.2 times 28 divided by 0.96. V gives me 35. For the motion from A to B, find the work done by the train's engine given that the work done against the resistance to the motion. The work done by driving force. Change in K plus change in P plus work done by resistance. This is 2.3 times 10 power 6. No P involved. Half M V square minus U square work done by dF. So 200,000 into 35 square minus 28 square plus 2.3 into 10 power 6. The work done by driving force is 4.64464 on 2, 3, 4, 5. Okay. Question 9. The diagram shows a vertical cross section ABC of a surface. The part of the surface containing AB is smooth and A is 2.5 above the level of B. The part of the containing BC is rough and is at 45 degrees, the distance BC is 4, a particle of mass 0.2 kgs is released from rest and is in contact with the surface and with the straight line BC. The coefficient of friction between B and the surface is zero point 0.4, um, zero point 0.2 kgs. Let's draw this here. 0 point 0.4 R. Okay, find the speed of with B with which B reaches A. So for the first part of the motion, change in K should be equals to the change in B. If I want to equate the two, I'll have to change the sign. So minus mg and h. What am I trying to do here? I'm trying to find the ending speed for the first part of the motion, m v square minus 0 square. So v square equals to 50, v equals to root of 50. Okay, then when the second part of the motion starts, work done by driving force, change in k, plus change in p, plus work done by resistance. Work done by driving force, that's 0. There's no driving force. Half m. Find the speed. So that's what I'm trying to find. The previous speed is u square, so 50. P is we have taken both as positive. I need to change this to positive sign. There's no need to take a negative since I know that K is going to be positive. It's only when K is negative you do that. It's going to create a confusion if I do it minus because it's falling now. M G H is 4 sine 45. Work done by resistance. The resistance is constant. It's zero point 0.4 times 2 cos 45. And the distance it's traveling is 4. So I've done mu into R into 4. Let's solve and see if we get the correct answer. Nine 9.16. The calculator solve this for me. This was question 9. Let's do the last question for this marathon. It says a car of mass 1600 kgs moves with a constant power of 14,000. As it travels along a straight horizontal road, the car takes 25 seconds to travel between points A and B. Find the work done by the car's engine. Okay, so work done is power into time. We've done that in the lectures. Power is 14,000 times 25. 350,000. The resistance to the motion is equals to this. The car has an acceleration at b of this and a and b of this and that. Find the gain in kinetic energy by the car in moving from A to B. So I have to draw these situations at A first. There's the 2 to 35. I can say that this driving force is 14,000 divided by the V. Um, 1600. So 14,000 over V minus 235 equals to 1600 A, and A in this case is 0.5. So 1600 into zero point 0.5 plus 235, 14,000 divided by answer gives me a very weird V, 13.5266. Okay, yeah, 13.53. I'm doing it fine. And for the other part of the motion, I'm going to do 14,000 upon V again. Should have been U, call that U, that I can later call that V. 235, 1600, and the acceleration is now 0.25. So 14,000 over V minus 235 equals to 1600 into 0.25 now. So that's 22.05. So again, its kinetic energy is half 1600, 22.05 minus 13.53 squares. Two, four, two, 300. Okay, I'd rather round up to correct to three significant figures than give you the exact number because it's slightly different from what I'm getting here. Okay, still round off to 300, but I have to be careful because it's 2490. Maybe they've taken exact numbers. I think they have taken exact numbers. So 2800 over 207. Yeah, they've taken exact numbers, which is why their answers are more precise, but it's absolutely fine here as well. Though you should be be a bit careful. Let me check. I want my answers to be precise as well, which is why I'm checking. Yeah, it's 242490. Okay, then the distance AB. So part 3 is simple then. Work done by DF, change in K, plus change in P, plus work done by R, work done by driving force. Is what I found in the first part. The change in K is 242490. The change in PE is 0 because it's a horizontal road. And the work done by the resistance is 235 into the distance t. So 350,000, 242490 divided by 235. I'm getting a distance of 457.48. Round it off to three significant figures gives me 457. That's the end of the first marathon. I'll be back with another one soon. Please make sure to like and subscribe if you're watching this video. Thank you.